Hi friends, welcome to Learn Binary Operations. On set n, an operation is defined as a star b is equal to a plus b plus ab. How can we check whether it is a binary operation? What is a binary operation? Binary operation on a set A is a function from a cross A to A. A function. Look at this question. Determine whether or not that function definition of star given below gives a binary operation. In the event that star is not a binary operation, give its justification. And the rule given to us is on set z plus. Define star operation by a star b is equal to a minus b. Here on z plus, the set given to us is z plus. Z plus means positive integers. So here we have the codomain. Codomain should be the set given. The positive integers 1, 2, 3, 4, etc. till infinity. And the domain should be A cross A. What is A cross A? A cross A is set of all possible pairs made out of these. So the pairs can be something like 1, 2, 4, 9, 7, 3, 2, 1, etc. etc. Many pairs. Now each of these pairs will be related to a single number. How? The rule is given to us. Any pair we take. Let me take one pair, say for example 8, 6. 8, 6. Which element will it be related to? To get that 8, 6. 8 is the first number, 6 is the second number. So 8 star 6 we say. That is the image. That is to be obtained by doing this rule, it seems 8 minus 6. Here 8, 6, 8 star 6, the image will be 8 minus 6, which is 2. First number minus second number is the rule. Let's go for another one. 8, 3, the image should be 8 minus 3, which is 5. 8, 4, that is 8 minus 4, which is equal to 4. But look here. 1, 2. What would be its image according to this rule? Rule says first number minus second number. A star b is a minus b. So 1 star 2 or image of the pair 1, 2 should be 1 minus 2. And what is 1 minus 2? Minus 1. Minus 1 cannot be there in the z plus. In the codomain, minus 1 is not available. Hence, 1, 2 does not have an image in this codomain given to us. Because of that, this operation given to us is not a function. For a function, every element should have a unique image. We could get an element which doesn't have an image here. So, it fails to be a function. Since it is not a function, it is not a binary operation. Let's go for another example. One more rule, another operation. Let's check whether it is a binary operation. To check whether it is a binary operation, what we need to check is whether it is a function. So this time again, various pairs will be taken and the image has to be obtained by multiplying the first number with the second number. So let's take some arrows. 1, 2. 1, 2. The result should be 1 into 2. 1 into 2 is 2. Yes, this time 1, 2 has an image. Okay, let's take another one. If you take 4, 9, 4 nines are, that is also positive integer. Whatever 4 into 9 is a positive integer. So every pair will have a product and the product will be unique. A star B is A into B. A into B is unique. Uniquely present. It belongs to Z plus itself. Any two positive numbers multiply, you will get a positive integer. And the result will be unique because the product cannot be different products. A into B, whichever A and B you are taking, you will get a unique product. Hence, every pair will have a unique image which makes it a function. If it is a function, it is a binary operation. So, if the rule given to us is following the conditions of a function, we can say it's a binary operation. Basically, the domain should be the cross product of the set given and the codomain should be the set itself. Every pair is turned into single number. That is what each operation does. But for it to be a binary operation, it need to be a function. Like we saw here, one pair was not having an image, so it was not a function. Here, every pair will have a unique image, hence it's a function. Since it is a function, this one is binary operation, and this is not binary operation in Z plus. Of course, if this set given was only set of integers, this positive numbers restriction, if it was not there, yes, then a minus b would have been a binary operation, because like here 1 minus 2 is minus 1. Minus 1 will belong to z, though it is not in z plus. That way it could have been, the same rule could have been a binary operation. Another example is on set of real numbers, defined as a star b equal to ab square. Set of real numbers means all numbers from minus infinity to plus infinity. Not only these negative and positive integers, all the decimals, fractions, everything, that is right from minus infinity to plus infinity, that is set of real numbers. This time set A is set of real numbers. So that is kept as the codomain, and the domain should be its cross product. That means all possible pairs done using all the real numbers. Now, each pair, how will it be related to each single element? The rule is given here. A star B is equal to AB square. First number star second number is equal to first number into square of the second number. So for example, if you're going for 7 star 3, that is the image of 7 3, that will be 7 is the first number, 3 is the second number. 7 into 3 square. 3 square is 9. 7 into 9, that is 63. So 7, 3 pair will be related to 63 out here. Yes, there is a number associated to 7, 3 and only one number, that is a unique number. So for this element, it's a unique element. In fact, for every real number that we take A star B, when you multiply the first number and the square of the second number, we will definitely get a real number as the answer, and that answer will be unique. We won't get different answers. For any single A and B, the same answer, unique answer. Hence, the image is a unique number present in the codomain. So, this can be treated as a function. Every element has a unique image. So it's a function, and if it is a function, it is a binary operation. Now let's go for another example where the set given is z plus. Z plus means only positive integers, no fractions, no decimals, no negative, not even zero. Z plus, only positive integers. And what is the rule here? A star B is modulus of A minus B. Modulus of A minus B. So for any pair, say 7, 3. 7 is the first number, 3 is the second number. First number minus second number, 7 minus 3 is 4, and then take the modulus, that is 4. 4 will be positive. So if you go for 4, 6, first is 4, second is 6. So first minus second, 4 minus 6 minus 2. But you are taking a modulus. Because of that, you will be getting the result as a positive number. 4 minus 6 modulus is 2. The image of 4, 6 will be 2. A unique answer for every pair. So, for every A and B, modulus of A minus B is defined to be a positive number. It will belong to positive integer and the result is unique. Hence, this rule is also a function. And if it is a function, it's a binary operation. Next, on set R, define an operation A star B by A. What is it? A star B is A? Yes. First number star second number, the result should be the first number. That is what the rule says. We want to check whether it is a binary operation. And what is the set given to us? Set of real numbers. All negative and positive numbers right from minus infinity to plus infinity, including all fractions, decimals, everything. So, the domain will be R cross R. All the pairs made out of real numbers. Each pair, what will be the image of 8, 6? 8 comma 6 image will be 8 itself. That is what the rule says. A star B is A. The image of A comma B is A. First number is the result. So 8 comma 6 image will be 8. 8 comma 0 also has the image 8 itself. That is okay. That doesn't fail it to be a function. Each element should have a unique image. 8 comma 6 has a unique image 8. 8 comma 0 also has a unique image 8. No second image possible for 8 comma 0. Both of them having same image, that doesn't violate the definition of function. So, if you go for the general element method, A star B is A, which is definitely one of the elements from the given set. Hence, it is a function and therefore it is a binary operation. Let's go for another example on Z. Z is set of integers, all negative and positive. Here negative numbers are also involved. And what is the rule given to us? A star B is equal to A raised to B. That means 2 star 3 will be 2 raised to the power 3. 7 star 3, 7 comma 3 will be related to 7 raised to the power 3, 7 cube, which is an integer. Any integer raised to the power an integer will be a integer. But remember, in case the power is negative, what will happen? Say for example, 2 star minus 1 if you are calculating. 2 star minus 1 according to the rule it should be 2 raised to minus 1 and we know 2 raised to minus 1 is half. Where is half available in the codomain? Half is a fraction, that's not an integer. So 2 comma minus 1 will not have an image. That half does not belong to the codomain. Therefore, this is a counterexample for it to be a function. One particular element doesn't have an image. We may be able to find many more examples, but we need to just highlight one example that goes against the definition, which counters the definition. To prove the statement is not true, we can go for a counterexample. This is a counterexample, a numerical counterexample, a numerical example which goes against the definition. But don't try giving many examples when a statement is going to be proved true. Any number of examples will not work. For that, we need to do it by general element. But since it was not a binary operation, we can just highlight one pair which violates the definition. Hence, this given rule is not a binary operation. In the next example, the set given to us is very specific. Set 1, 2, 3, 4, 5, only 5 elements. And the rule given is A star B is equal to LCM of A and B. LCM of A and B is the result. Here set A, 1, 2, 3, 4, 5 only. And A cross A will be the pairs made out of these many numbers only. No other pair will be involved. Then, how will we find the image? What is the LCM of 1 and 4? LCM of 1 and 4 is 4. What is the LCM of 2 and 4? LCM of 2 and 4 also is 4. Yes, the images are present here. And of course, for any pair, there is a unique LCM. But look here. Suppose we take the pair 2, 3. So what is the image of 2, 3? LCM of 2 and 3. LCM of 2 and 3 is 6, which is not available in the codomain. Hence, this operation given to us cannot be a function. It fails to be a function, hence, it is not a binary operation. Here again, we have explained it using a counterexample. One particular pair which goes against the rule, against the requirement of function. One element doesn't have an image, then we cannot call it a function. If it is not a function, it's not a binary operation. But in case we were given LCM the same rule on another set. See here the set is set of natural numbers. Complete natural numbers set given to you. Rule is the same. LCM of A and B. Here also LCM of A and B is the rule for A star B. Now this situation will not happen. The image of 2 comma 3, the LCM of 2 and 3, which is 6, which was not available here, but if you had taken the set as set of natural numbers, 6 is also available there. Any natural number. Oh, that means LCM of A and B is any natural number. A and B LCM will be a natural number, and that will be a unique result. So it is a function. This time it is a function because every pair has a unique LCM. Hence, this operation is a binary operation. Found it useful? Don't forget to subscribe Merit Joseph channel for variety of examples and various topics.